You spent a lot of time and money on your control panel and landed your field wires.
Don't rush the startup. This is a critical time that you can save yourself a lot of costly mistakes. Now, I know a group of you will shudder at the fact that I did not show the perfect job at startup and commissioning. But before you actually comment, think back to your first jobs, because that's kind of what we're trying to do here, is walk you through some of the mistakes that we made early on. Honestly, the mistakes I'm showing you here are mistakes we actually made on this panel. The chance of it going perfectly is pretty much zero. And while we could simply snap our fingers and say that all this worked in this video series, I really want to share with you the mistakes that we made, how we worked through them, and how we still had some costly mistakes, but they weren't as expensive as they could have been.
First, think about who actually needs to be there. Definitely not your customer.
This is one of my early jobs. It nearly sent me out of the industry. We had the machine mechanically built. That evening, we finished wiring it up, and my boss called the customer in to watch the initial power up, and it went horribly.
But do have a partner with you during your initial startup.
Yes, because you're going to need someone there, one, just to keep an eye and make sure that you don't do something crazy, but also you're checking a meter here, maybe the buttons over there. It'll keep us from doing things that probably aren't that safe. Let's talk through the steps of powering this up.
First, speaking of safety, you need to put your safety glasses on.
One important tip, if you're having someone else do your installation, is where they land their main power, put something really obvious that they have to remove to actually land it that tells them the voltage and the amps that they need. Back when we were building a lot of panels and shipping them out for other people to install, it was surprising the time that they got there and the customer told me to build a panel for 230 volts. And they had told the electrician to run a 480 volt service. So this has saved us a ton of times of burning some very expensive equipment up. Make sure your main disconnect is turned off. And then we want to open up all of our fuses and circuit breakers. That way we can test things one at a time and press all the e-stops on the equipment.
Make sure you have a good quality meter. Today we're using the Fluke 381 with the detachable display so you don't have to be inside the control panel when checking your voltage. We're going to start by checking the power on our main disconnect going in at the top. And we have 120 volts.
We can switch our power on, and that's going to take the 120 volt and it's going to feed it up to the top of our fuses. Now, it's very important that we only test one of these at a time. And we want to start with the one that powers our transformer first. Now, a little bit of a uniqueness about our setup is this is in our training center, so we are feeding it 120 volt wall power, but we needed 230 volts. We are back feeding this transformer, and we have videos on that and a lot of other good, useful tips. You'll find a link to that in the description. You can double check that I do have 120 volt coming up to the top of my fuses, and I do. And I'm going to close these one at a time. So I'm going to power up my transformer. That feeds 120 volt in here. And that should hit 230 volt out right here. And the issue that you really have to look out for are these jumpers. If I have not configured these jumpers properly, then we can end up with the wrong voltage right here. And I had this happen on a job early on, almost very devastatingly, as we were supposed to be taking 480 and dropping it to 120. But we wired the 480 to the 120 side of the transformer. So instead of dividing our voltage by 4, we multiplied it by 4. Yeah, we had like 1800 volts going out of that transformer. My 230 volts should be right here. And actually, hey, can you adjust that? They can't see this. Or wait. We have this remote display, so we put this right where we need to measure, and we have 230 volt. Next, we're going to check our 24 volt, and we do that with this fuse right here. And immediately that should power up all of our circuits. So we do. It's always exciting when you start a panel up and you see some flashing lights. I'm going to check my 24 volt right here. And it appears I have nothing.
The issue is Tim had it on AC and he needed to be on DC.
And this is a big issue that I do and you do when you come to my class, is we have to know, are we measuring AC? Are we measuring DC? And as much as I love this Fluke 381, that's why I still think I prefer the T61000 when doing power up tests, mainly because it has an AC DC mode and it detects it and it switches for you. Here's where this Fluke proving unit can really come in handy. So I wanted to test for DC power. I can simulate DC power here.
Will you go this way? This way.
Yeah. There we go. Oh, look at there, guys. If we actually turn the light on, you can see what we're doing now.
I was going to detach it.
Oh, go ahead. Yeah, there we go. Yes, so we'll just detach the remote display. And there now, I know you can see what we're doing. And if we touch the positive, and negative, then we know we have 250 volt. And if I switch to AC and I try it, then notice it shows 0 volt. And that tells us we're in the wrong mode on our meter. I gotta admit, guys, I like for general video, and you may see this in a lot of future videos. We're on DC, and now if I check my 24 volts, I have 24 volt. So next we need to test our I/O, and we can test our inputs right now, but before we can test our outputs, we have to get our safety working. We're using a Banner SC10 in this, and we're going to have detailed videos on how we configured it, but we already have a test program configured for it, and we have a test program in our PLC so we can test. That's too many word tests.
It's a lot of testing.
It's a lot of testing. But let's go do it. I'm going to click on the live mode button. And Amber, can you stick your hand in the light curtain? And we are not getting anything on the light curtain. And our transmitter is saying error 25. And according to Banner's instruction manual, this is an emitter error that can occur if the ID input, pin 3 orange, is not connected to the plus 24 volt DC. And sure enough, this wire is still tucked into the wire nut because I thought we didn't need it. So I'm going to put 24 volt on it. And assume that we have to cycle power to get the error to go away.
It's just it. Tim cycled the power, and now we have twinkly light.
Now, before we can actually get our safety to work, we need to do our safety reset, which is coming over a network connection, which leads us to our next problem. Our item is coming over the ET200SP by Siemens, and I don't have any lights on it. Initially, I thought that its I/O power was the same as the communications power, but after looking closely at the manual, we actually need positive and negative connected to each one of these modules. Which brings us to our next issue is I don't have nearly enough plus and minus 24 volts for these additions. I did not put nearly enough foresight into the number of terminals that I'm going to need. Now, the issue that I can run into here is as I shift these down, are all these wires long enough? So make sure that you think about the future, especially on these positive negatives where you know if all these wires short. Another thing that jumps out at me right here, and I might as well highlight it, is this is a ground wire, but it is gray. And for the most part, people expect grounds to be green. So we're going to go ahead and stick a label on this while we're at it. And that looks much better. Also, I was able to relocate most of them up here. But realize that this mistake here took about 2 hours to fix. And right away, we have some indicator lights, so we're probably looking good here. Now let's go ahead and test our buttons while we're here. So press the green button. Good. Red. Yep. Blue. And yellow. Before we can test our outputs, we need to finish testing our safety circuit. So we found the problem with our light curtain, and now if we break the beam, it works. Amber, can you open up the gate? And we see it open up. And finally we press the E-stop, and we see it. And now if we press the blue button, we should see everything go green. And we even heard the safety contactors pull in.
Let's test our light.
I have some temporary code to test the lights, and I would strongly urge you to do this and do not use the forces. I've got a lot of videos where we talk about the pitfalls of using forces, so I'm going to go ahead and toggle the green light.
The green light is on. And the red light is on. The blue. And our yellow. So our testing went well. And we have our solenoid. Now the gate will open. And now it won't.
We're going to use the PLC tool Sim ALP2 to test our analog signals. We're going to put a current source mode, and at the bottom it says the red is the PLC input and the black is the common. I'm going to take the red wire to the third terminal down and the black to the fourth terminal down. And if I bring it up to 4 milliamp, it's showing roughly 0. And if I bring it to 20, then it's 27,700, which is the full scale of this. And I'm going to test my analog output up here because this got a little easier view. And right now it is showing 0. And I'll start putting some value. Oh, right away we have something. So around 100. Yep, we got about 9.2. And there is a reason for that strange scaling, which we're going to talk about when we go over the details of the Siemens ET200SP. We have a video where we did the initial setup of the Yamaha Scaro, really configuring its IP address, setting a few limits, and creating the test program that we're using right now. I'm going to power Yamaha's RCX 340. And we're just going to use the basic jog just to make sure that all our connections are working and all our access are working. So it says that our emergency stop is on right now. And we actually have 2 emergency stops. We have our hardwire emergency stop. And in my test program, I see that our safety output's not on. And when Amber hits the blue button, that'll be our safety reset. And that turns that on. Then in my robot program, I also have its Ethernet IP e-stop. So we're going to toggle that. And now it should be ready to turn the servo on. I'm going to toggle the servo on. And after turning on our e-stop, we do need to reset the alarm since the robot does consider that an alarm. Next, let's try to jog our spindle up. All right, it goes up. It goes down. Then go forward and backwards. It goes right. And it goes left. And this gear also can rotate. And it rotates both directions. Just to reiterate why you want to do one thing at a time is we're making nice steady progress. But I can tell you that the spindle motor did not work out well when we did this on the initial trial. I'm not going to actually show you the video footage of it, but here is the result of it. It was very scary. And what we found is this DC controller for the spindle motor, even though it had a potentiometer input to wire into these 3 terminals, you cannot connect the common of this to the common of your 24-volt power supply. So when we did that, we ended up with a runaway condition of that spindle motor. Pretty much it ran wide open. So additionally, we needed this analog module to go on top of the DC drive. Now the rest of the wiring portion of your power up will be pretty much a repeat of these processes.
Click here